Hi, and welcome back. In this next lesson, we're going to be talking about the vSphere pod service, the feature inside vSphere with Tanzu. And our objectives here is we're going to first talk about both the characteristics and the capabilities of the pod service, which will be the service that's going to be scheduling the running of the actual vSphere pod itself. So let's go ahead and dig in. The pod service is the ability for us inside vSphere to natively deploy and run containers as these things we're calling vSphere pods. So my pods, if you look on the screenshot over here on the right, they show up right in my vSphere client's inventory. They look sneakingly like a virtual machine. Because technically, there's some differences. That's actually what we're doing, okay? We're letting these vSphere pods, they're running underneath our container runtime executive, our CRX, and they're going to have all the characteristics just like all the virtual machines that are running on your vSphere environment. Which what that means is all of the tools, the techniques, the information, the background, the optimization tricks, troubleshooting tricks that you already know about being able to troubleshoot virtual machines, all of that knowledge base suddenly now transfers right over here for us when it comes to looking at our vSphere pods. So you can see inside here, it provides as much security and isolation and performance as virtual machines. So my vSphere pods and my virtual machines are really kind of on an equal platform here when it comes from the vSphere perspective. They are going to be visible in vSphere objects. That's going to be an important thing to remember when we go look at our Tanzu Kubernetes grid service. Those pods there are really, from the vSphere perspective, going to be invisible to us. We won't have visibility into them. Running them as vSphere pods, they show up right inside our vSphere client for us to take a look at. The pods, we say here, they're compatible with HA and DRS. Now, we're going to clarify that a little bit in the next slide, and I'm going to clarify it some now. Your pods, when we go to deploy them, HA has a feature called admission control. And admission control will be honored if we go to try to deploy a vSphere pod that would violate my admission control constraints that I put on my cluster using vSphere HA. From a DRS perspective, vSphere pods are not vMotionable, okay? That is something that isn't just there yet. So how are they DRS compatible is DRS does do recommendations on where to power on a virtual machine as to which ESX host. So you could see that right over here in our next slide. The resource management using DRS is just for the initial ESXi host placement as to which ESX host would have the most amount of capacity to run the specific vSphere pod. Those vSphere pods are going to have a very strong isolation from the Photon OS, which is running down here. So the CRX, the platform, the OS that's sitting down here that we're running on top of is Photon OS. We make sure that there's a strong isolation from your container that's running inside this from the operating system. Obviously, if it could breach the operating system, if it was hacked or compromised, it would have gained an elevated gain of access, and we want to prevent that. It has the same level of resource isolation as VMs. Think about how your VMs are isolated from each other. Your vSphere pods are going to fall in the same category. Your pods are OCI compatible. Okay, that's an important thing. That's a standard that says, will the container run on different platforms? And these vSphere pods are going to be the equivalent of a Kubernetes container host or your worker node. Remember, your pods, you can run multiple on a single ESX host. So the formula of how many VMs can I get on an ESX host, guys, these are just like VMs, right? The correct answer is it depends. How big is your ESX host? How big are your VMs? That's going to give me an idea of how many VMs I could put on the host. The same thing's going to be true here about your vSphere pods. How big are your vSphere pods in CPU and RAM? How big is your ESXi host? What other workloads are you running on your ESXi host is going to determine how many you can get on there. To prove the point a little bit, we wanted you to see what a vSphere pod would look like if I SSH'd into an ESX host and I went to the data store where this vSphere pod is running. You'll notice I've got all the familiar files that I'm already used to seeing as a virtual machine. So I'm going to have my flat file. I'm going to have my VMX file, right? I'm going to have an NVRAM. I got a vSwap, all the familiar ones. It looks like and it behaves like a virtual machine. Now, when we're powering on or something's going on in a virtual machine, we're going to be writing out here to some log files. That same operating procedure is when something's going on that we log it into the VMware log or potentially the guest log still exists, but there's going to be some differences when you're running a vSphere pod. Spherelet, for example, would be anything that he has to do, that's the equivalent of kubelet, would be writing those information or those diagnostic messages out to your guest.log. So this was a short lesson. We went over both the characteristics and the capabilities of our vSphere pod service and how the service is the thing that's actually deploying the vSphere pods. And we dug a little bit into the vSphere pods as well, some of the details. So to help you understand this better, we're going to go ahead and do two labs, okay? We're going to first deploy an application, a container that's going to run in our vSphere pod. So make sure inside that lab, you go into the vSphere client and you can see it showing up in the inventory. And then after we see that, we're going to go ahead and scale that deployment out. So instead of having a single pod, we're going to have multiple pods, which is going to be our normal behavior that we want. We don't want a single pod because that's a single point of failure. Reality, when we're deploying some type of application or a microservice in a pod, we're typically going to want a replicas equal to 3 so that we've got a higher degree of availability and possibly capacity as well. So, as I said, lab number 7, go ahead and deploy the vSphere pod. You will be using the CLI to do that. That's the only way to deploy it. You can't do it via the HTML5 client. View it. That's going to be you taking a look in the HTML5 client and seeing that you can locate it. And then once you've done that, continue right on to the next lab, lab number 8. You're going to go ahead and use the kubectl command again, and you're going to scale it out. We're giving you the edited manifest file that we've already increased the replica count to 3. You're simply just going to do a kubectl apply that manifest file, which is the same deployment name. So we're not doing a new one. We're updating an existing one because it's the same deployment name. So again, view that inside the vSphere client. So go ahead and get started on the labs and take a break when you're done and come on back and join me with our next lesson. We're going to talk about how vSphere with Tanzu storage is being implemented for your containers.